Hello, it's day 142. More waves. So we're exploring mechanical waves and looking at vocabulary related to waves, seeing how changing one characteristic of a wave affects the other ones. Those are the big goals for yesterday and today. So yesterday you should have played around with this wave simulator, this wave generator, waves on a string, and you should have seen that when you increase the amplitude, that increases the height of the wave, and that you can use the tool to pause, and you can set a ruler to the equilibrium line, and you can get a height there. That's your amplitude. And that you can measure things like wavelength, right, from peak to peak. We're going to cover what those terms mean today. All right, but there's a length of one wave would be from where basically where it repeats, right? Where you get the same shape over and over again. So here's one wave. Some people draw waves this way from peak to peak. Some measure them from trough to trough. This one looks like it's about a little bit less than 2.25 centimeters long. Or sorry, these are not quarters. These are what would you call those? Fifths. So a little bit less than 2 1/5. So, yeah, you can measure all those things. And frequency, we could use a timer and see how many waves go by in a certain period of time, right? When I press play. So it's 1, 2, 3. I'm just counting as they pass my cursor. 4, 5, and I could, you know, restart my stopwatch here as a wave goes by and use it as a timer and figure that out. Lots of other things that you can get from waves, just in terms of their structure, and we'll continue to look at those things today. Okay. Um, One thing that I asked you to do yesterday was to trace a wave and to try to see what happens uh, to a specific point as time goes by. So we're going to slow this wave down a little bit. There we go. And I want you to. Oh, that's too much. All right, that's better. So I want you to just pick one of these green dots and follow its motion. So I'm going to pause. So this green dot is right here. I'm going to put the edge of this vertical ruler, the right edge of it, on this green dot right here. And let's just press play and see what happens to the green dot. Most people think, oh, it's going to move along with the peaks of the wave. Right? That's how these things look. That's the illusion that they give. But, okay, where is it now? Which way did it go? Up or down? It went up. Did it go to the right? No, it didn't. All right, it's here now. It was down here. Now it's here. Let's play again. Okay, where is it now? Back down here. Where is it now? Back up there. It's the same green dot. And I'll just let it play now. And if you watch, it's just bobbing up and down. Right? If you follow this wave, if you follow my cursor here, it's definitely the peak of the wave is moving to the right, which means this is transferring energy this way. But the individual pieces of the wave are just getting energy, losing energy, getting energy, losing energy, getting, losing, up, down, getting, losing, right? That's all they're doing. So this is just a way of transferring energy. The green dot gets energy, then it gives it to the particle that's next to it, and when it does that, it loses some energy and it goes back down. And then after some time goes by, the particle to the left of the green one, boop, bumps it, gives it some energy, sends it back up, and then it loses and goes back down. So these are mechanical waves. They transfer energy by touching each other. That's what's happening now. You're listening to me, and that's because there's a speaker on your device and it's vibrating and it's banging into air, and it's causing that air to move, and that one air particle bumps into another one, and each of those little particles, they're actually molecules, each one bumps into another one. They keep bumping until one of them bumps into my ear, and I feel the vibrations, and my brain goes, oh, sound, and it interprets it. Mechanical waves. Okay, for today, a light activity. We're going to do some guided reading, 2 guided reading activities. Oops, I forgot to change this. So this is on Schoology, so you don't have to save it to your Google Docs. It's on Schoology. And let me just show you what it looks like, though. I already opened it. Fun. It's like everything is frozen. Great. Okay. Well, anyway, we're back. Oop. What? Distance learning for the win. Okay. So, guided reading. I've given you a reading from my favorite physics textbook, which is not the textbook that we have. The textbook we have is not the most exciting, but this one is great. It's a conceptual physics book. I really enjoy it. The reading is light and easy, and hopefully fairly kid friendly. So I've given you that. These are all the fill in the blank sentences and questions and whatnot. The reading itself, there's a link. It will take you to a folder. I'm sure the folder will take a couple years to open, because why not? Oh, there it is. It'll take you to this folder called Guided Reading, Waves and Vibration. And each page is its own little JPEG. So you got to open up each one. And if you have any issues with this, let me know. I can put this in a different format if you're not able to access it, or if you have a hard time. But you should be able to look at this and do things like zoom in and read about waves. All right. So talk about pendulums. You've seen these before. All right, maybe the Newton's cradle, where there's 5 of them. Yeah, everything's backwards, and you knock this one. Wait, you knock this one, and then that one moves. All right. So pendulum. You can go to the next image. I'm not going to go through all these because it's going to take forever. But it's good reading and describes all of the basics of a wave and things like wavelength and amplitude, and where we see waves and where we don't see waves, but where they exist, like here on a transmission tower. So all that good stuff. There's a little bit more reading, covering, again, what's a wave, just in a different way, medium, how particles interact, and that waves transport energy and not matter. That's what we were just talking about with the green dots on the waves on a string. All right. So that energy is being transported, but not actual physical material. The material just stays put. Again, you can do this at home. You take something light like a styrofoam peanut or a piece of grass or a leaf or a hair or anything. You put it in a little bowl of water and you drop a pebble in there. You drop a penny in there. The waves will make that thing bob up and down. Even though the waves move out, they won't make the thing that's floating on the water move out. It'll just basically stay put. So there's a reading for that. That link is here. And that takes you to the physics classroom where they talk about what is a wave. All right. So we're talking about critical things like equilibrium, talking about pulses. What's a pulse? I'm giving you some examples and things like that of what all this looks like. If you want to take it further, you can mess around with a little lab that we're going to do later. And there's some questions down here to answer. And we'll talk about those later as well. Okay, so that's it. Light day 142. Hope you're having a good day, a good week. I'll add some more quiz retakes over the weekend. And that's it. All right. Stay safe out there. Oh, yeah. Don't inject yourself with Lysol. There was a press conference that mentioned something about taking, what do you call them? Disinfectants. Like putting disinfectants in your body. Don't do that. All right? Don't do that. That'd be bad. Okay. Be cool. See you Monday.